Calculating standard deviation is one thing. But what if you want to estimate standard deviation of the population based on what you know from your sample? That adds a twist that we will learn about now. Recall that our ultimate goal is to describe the population of scores. When you do not know the population mean, the best estimate is the sample mean. They're always the same. Unfortunately, estimating variability is not so simple. If we have access to the entire population, we can directly calculate the variance in standard deviation. Most of the time, however, we have neither the time nor inclination nor the ability to measure the entire population. Instead, we measure a sample drawn from the population and then use what we learn from the sample to estimate the value for the population. When we don't know the population scores, we must estimate. So let's clarify the difference between computing and estimating. When you compute the standard deviation of a sample, you use n in the denominator. You can do this because you have all of the scores from the sample. Likewise, if you were to compute the standard deviation of the population, you would use n in the denominator because you have all of the scores in the population. But when you want to use data from a sample to estimate the standard deviation of the population, you must use n minus 1 in the denominator. This denominator will be n if we use it for calculation, but will be n minus 1 if we plan to use the sample standard deviation to estimate the population standard deviation. So this is the final formula that you should use from now on if you plan to calculate the standard deviation from sample data to be used to represent a population parameter. In all parametric statistics, this is the formula that will be used. I will show you how to use this formula in another video.